continuing topic 8.2, and we're looking at example 9. But before we do that, we're going to look off to that left-hand column here and look at this in addition part. So we really could have used this on the last example, but if you were given something, if you're given the time that something happens, then you can use either shift plus for the integral or shift minus for the derivative, okay, to find the derivative or the integral. If you are not given the time that something happens, so they ask for when or what time it happens, that's what we did in example 8. You must find the derivative or the integral and use the graphs to do that. And you graph that last line, that whatever it's equal to is a horizontal line, and then use your points of intersection. All right, so in example 9, we've got the velocity of a particle that is moving strictly horizontally is given by the function. So I see velocity, I'm going to write, I am very proud dude. I notice I'm starting with velocity, so I'm going to circle it. It gives me an interval from 0 to 7, measured in feet per second. At what value of t is the particle furthest to the right if the particle is initially 4 feet to the right? So there's your initial condition. So when time equals 0, we know that our function or our position is equal to 4. The first thing I really need to do is figure out where our velocity is equal to 0 so I can figure out where our other critical points are. So I'm going to take my velocity of t, 2t cosine t minus 2t plus 5, and set it equal to 0. Really, I need to discover what am I really supposed to be doing. When I say furthest to the right, remember we could scroll up here. And furthest to the right means I need to find the maximum of the position. So if we're talking about maximum of the position and I'm starting with velocity, I know I'm going to go to position, so that means I have to integrate somewhere. But before I can integrate, and because I'm doing max, it's like absolute max. Remember how we did the t-charts? I need to find the other critical numbers. So let's find, this is a t, not a plus sign. Let's find those values of t using our calculator. So what I have already done is I've already put in the function into F1. Now I'm going to adjust my window because it said I only have to be allowed to be between 0 and 7. So I'm going to go menu, analyze graph. Though I could probably get that from this window, I'm going to just make sure, sorry, not analyze graph, window zoom, window settings. From 0 to 7, and then click OK. And then, so it looks like we've got 2 other values where we're going to have critical numbers. So menu, analyze graph, 0 to the left, to the right. And then menu, analyze graph, 0 to the left, to the right. Now for me, I would probably go ahead and store these values. So I'd click once, click twice, Control C. I'm going to come over here, I'm going to hit Control V. And I'm going to go Control var and type an A. So I know that that first value is going to be an A. And it doesn't hurt. So T equals 1.89543. And you can also somewhere say, if you want to say let A equal 1.89543, the graders would actually read that, and then you could just write A instead of that number every time you need it. All right. Then I'm going to grab the other one. So I'm going to go click once, click twice, Control C. Come here, Control V. And then go Control var for store, and I'm going to put it into B. So 5.2653, 5.2653, and you could also say let B equal 5.2653. You have to write these down though on a free response and let the graders know you understood you found the critical numbers first. There's usually a point for that. All right, now I'm going to get a t-chart going. So we know that we've got to put our critical numbers in the t-chart, and when we're doing an absolute max, the t-chart is our explanation. So this is going to be our t value, and this is going to be our position at t. So I'm going to put in a 0. I'm going to put in 1.89543. I'm going to put in 5.2653, and then we have to put in our other endpoint. So remember, when we're doing absolute, we have to test both of our endpoints. That's why I need the 0 and the 7. All right, so when we start, remember, we're always going to be starting here with an initial condition of 4 plus the integral from whatever this time is, 0, to whatever this time is here, 0, of, we're going to call it, we're going to integrate the velocity. And I don't need to rewrite that equation every time. Whenever I integrate from a number to itself, it's just 0. So this would be 4 plus 0 or just 0. And it's okay to do your work in the t-chart like that. So this one, I'm going to go from 4. I'm going to start at 4. I'm going to go from 0. And I'm just going to say go to A, because that's what we said the 1.89 is. V of t. Oh, technically I need to write a dt after these, huh? I'm going to go ahead and set this one up too. I know this one's going to go from 0 to b, v of t dt, because that's what we assigned the b. And this last one is going to go from 0 to 7 of v of t dt. All right, so let's go into our calculator and set those up. So I'm just going to be on my calculator screen here. I know I'm going to go 7 plus, and then we're going to go shift plus for my integral. And I'm going to go from 0. I'm going to do 0 to a first. So I'm going to go var a, and then var f1 of x dx. Okay, so 13.839. You said 13, right? 13. Woo! 13.839. All right, let's try the next one. And here's the beauty of this calculator. I can click on this. I'm going to click and hold. I can highlight it, or I could click it a couple times. Click once, click twice, click 3 times, and I should be able to get it highlighted, and I can do a Control C and then a Control V. And then instead of having A there, I could replace that with the var B and hit enter. And then I can do Control V again and replace that A with the 7 and hit enter. And then I've got all of the values that I needed. So negative 4.308, negative 4.308, and 1.705, 1.705. All right, so let's go look at what our values were here. Okay. Did I get my, no, they all came out different. Interesting. All right, I'm going to double check my calculator, make sure it's in the right mode. Nope, it is in the right mode. Okay, so it says what value is the particle furthest to the right? So furthest to the right, I'm going to go and look that up again, is when we have the maximum value of the position. So we know that the maximum value of the position would have happened when the y value is the biggest. So it looks like it happens at t equals 1.89. And this did say at what value of t. So all I need to do is list the t value. So at t equals 1.89543, the particle is farthest to the